Last one. And last one for the course, actually, to introduce new material. Um, we're just going to look at a couple different things, three different examples. And I've run the numbers ahead of time. So what I want you to do is follow along, try to figure out the stuff on your own, and then compare to my result. So first thing we need to do is determine, is it a prop or a mean, a proportion or a mean, which test to use, determine the null and alternate hypotheses, and all of the relevant information. So first example, Subway claims that the average length of a foot-long sub is 12.2 inches with a standard deviation of 0.2, standard deviation 0.2 inches. I measure 20 randomly selected subs and find the average length is 12 inches exactly. Does my data convince me to doubt their claim? Well, first of all, mean or proportion. They claim that the average length of a foot-long sub is 12.2 inches. That's an average, that's a mean. So we're going to be using either a z-test or a t-test. Their claim is that the population has a mean of 12.2. Sorry, 0.2. So 12.2. And their claim is the standard deviation is 0.2. So we're going to accept their claim about standard deviation, and that'll be a z-test. I measure 20 and find that the average length for my sample is exactly 12. Does my data convince me to doubt their claim? So if you run these numbers, and I'm not going to, I already did, but you know how to do this by now. You go to your z-test because we know sigma, and you pop these numbers in. Oh, and I'm sorry, I didn't say that I thought they were long or short, so our type is going to be the not equals. And if you run this, you ought to get a p-value of about 4.3E8, meaning 0.000, etc. Very, very small doubt. So yes, this would actually be convincing data that these numbers are wrong. If these numbers were right, okay, interpret this one more time. If these numbers were correct and the null hypothesis were correct, that the average actually is 12.2, then there's only a 0.0000008% chance that we would have gotten the results we did. So we're going to reject that null hypothesis. We're going to say, no, I don't think that this information is correct. All right. Second one. Subway also claims that more than half of its customers ask for cheese on their subs. I stood behind the line and observed 30 customers. 17 of them asked for cheese. Is this good evidence of Subway's claim? Okay, this time I'm trying to show that Subway is right. So their claim is that more than half of customers ask for cheese on their subs. That's a proportion. So their claim is that, well, P naught is 50%, right? That's the proportion in question. And their claim is that more than half. Okay. So this time, they are making the alternate hypothesis claim, and our null hypothesis is not the opposite of what they're claiming, but sort of the negation of what they're claiming. I observed 30 customers, so this is N of 30, and of those, the number of successes, the number of people that actually asked for cheese was 17. So fairly small sample, but a little bit more than half, right? Half would be 15 out of 30 instead of 17 out of 30. So you're going to use one prop z-test here. Go ahead and put those numbers in and see what you get. Pause me. You should end up with P equals 0.23. Okay, so remember what we're trying to do here. We're trying to show the alternate hypothesis. Here's our null hypothesis, and we're trying to show that that's untrue. Well, we tried to show it's untrue, and we got a very large amount of doubt. So we are going to fail to reject the null hypothesis, which means that we don't have very good evidence of Subway's claim. They're claiming more than half. Right? P always tells us how much doubt we have in the alternate hypothesis. That's what we're always trying to show. So we're trying to show that more than half order cheese, and we're finding we've got 23% doubt. We're going to fail to reject that hypothesis. But in the real world, we're going to say this is not sufficient evidence of Subway's claim. One more, and then we'll be out of here. The internet claims the average height for American males is 5'10", with standard deviation of 3 inches. Okay, so their claim, mu naught, is an average, not a proportion, is 5'10", which is 70 inches. They also claim that the standard deviation is 3 inches. I think the average is taller than that. So I think mu is greater than 70. That's my type of test, a one-tailed test. So I measure 25 American males and find the average height is 71 inches. So I measure 25 American males and the average of my sample is 71 inches. And I'm curious, is that sufficient evidence of my claim? Is that enough to reject the internet's claim in favor of mine? And if you run those numbers, you should get a P of 0.047. So depending on our significance level, right, that's less than 5%. So if we're operating at 5% significance level, then I would reject that claim that the internet made and say the average is likely taller. But if we were at the 1% significance level, that's far too much doubt. All right, I will probably talk to you again before the final exam. Not sure. If I don't, have a great summer.